All right, here's an example similar to the last problem on our test, and this is testing our understanding of interpreting a histogram. So what you see on the right is a histogram. It looks like it represents grades on the English test. So this part of the beginning says the histogram shows students' grades on their English test in Mr. Alex's class. So we see that this axis on the bottom represents grades on the quiz. So over here, these ranging from 40 to 100 represent the students' grades on the quiz. And then over here on the left, our vertical column represents the number of people. So the number of people that scored that specific score on their test. Okay, so the first part, we are just going to answer this based on our interpretation and understanding of the graph. So it says, Sarah says that 40 students scored a 15 on their quiz. Is she correct or incorrect? So we'll want to look at both of the axes and see what they represented. So it says, Sarah says that 40 students scored a 15 on their quiz. Is she correct or incorrect? So when I look at the grades on the quiz, I actually see that 15 isn't even in this scale. It starts at 40. So I know this is going to be incorrect or false. And I'll show you how they were trying to trick us here. So this is going to be incorrect because if we looked at this first column right here, see how it says 40, it ranges from 40 to 50, this one that I highlighted in green. And it's right here at about 15. So they were testing your understanding of reading in a histogram to see if you were going to switch those up and say that this was true. But it's actually incorrect because no scores of 15 are recorded. On our scale, it doesn't even show 15 as an option for a grade, so it's incorrect. All right, so how many students are in Mr. Alex's class? How can you tell? So part B is also testing our understanding of a histogram by seeing if we know how to get the total number of people that this accounted for. And the way we'll do this is we will calculate each bar and see what it represents, and then at the end we will add them all together. So see how this represents number of people, so that means wherever our bar is going to represent the frequency. So I'm going to say this one's about 15, this next one's about 25, I'm going to round them all up. This next one's about 35, this next one is about, I'm going to say it's at 45. This next one's at 40, and this one over here is at, I'm just going to say it's also at 25. Most of the time we'll be able to estimate a little bit better, but then we're just going to add them all together to see how many students total. And when we add those all together, let's see, we get 10, so 30, 60, 100, 160, and then 10, 25. So that would give us 185 students. And of course, once again, you can use a calculator. So that anytime we're getting a total, you'll take each frequency, so each bar, see how high it is on the histogram, and add all those frequencies together to know the total. All right, the very last question says, create a statistical question that represents the data on the histogram. So you should remember that a statistical question is a question that allows us to collect a certain amount of data. So the difference between a statistical question and a non-statistical question is that a statistical question gives us a variety of data, whereas a non-statistical question does not. So look at your histogram and think about which question, if you were collecting this data, what would be a question that you would have to ask in order to collect it? So basically this whole histogram represents grades on a quiz and the number of people that got that grade. So we can say, what grade did students receive on their English test or quiz, whichever one it is. And if we ask students this, we would definitely be able to collect the data to create this histogram. All right, hopefully that helps you with your last question on the test.